This particular engine has a oil control or oil pressure control valve where there's basically a high pressure and low pressure oil pressure setting. So we're going to turn that on so that when we run our variable valve timing, we are operating in the low pressure mode. So what I'm going to do is set this variable valve timing host up on the bottom of my screen and kind of rearrange my different things of interest so that we can kind of change the valve timing and see how that works. So what I'm doing here on the bottom is I'm presetting my cam angles for the exhaust and the intake so that I'm able to start out at the park position when I turn the controllers on. Now the next thing I'm going to do is make sure that I have enough actuator authority to drive these two valves properly. I'm able to save and store all these settings and all these windows using NISCM and save those values. So what I'll do now is just go ahead and basically save them by clicking on this purple disc for saving the default calibration. Now, when I turn the valve controllers on, you'll see that the system actually moved the exhaust cam, and now it's coming back to the value that we want it to be at there. You may see the same or a similar behavior with the intake cam. Alright, so now that we're at the initial condition that we want with the cams in their park position, we can start to, in the case of the exhaust cam, that particular cam on this engine advances from its park position. So we're going to go in basically steps of 5 degrees, and we'll advance the exhaust cam and retard the intake cam in 5-degree increments, and you can see how the controller is responding and moving the valves to the new position, and the cam to the new position. Now what we're trying to do here is show that at some point we can reduce the pumping loss that we see here and move these two lines a little bit closer together so that we can more or less demonstrate that we have reduced pumping loss in the engine. So far we've moved the cams 20 degrees. We haven't really observed much of a change in the pumping behavior of the engine. There's another 5. 5 more. So now we've moved 30 degrees, and we're starting to see that this pumping number is going down, and this indicated mean effective pressure, net mean effective pressure number is actually starting to rise a little bit. Okay, now it's gone even further, and now we'll go all the way to the park position. Now you can see this number is a fair bit lower. Actually, the engine really wants a little bit more air, and partially part of the issue is that it's running rich right now. So we're gonna work to kind of help it out a little bit, getting to that set point that we want. There, I've opened the throttle just a little bit more. And you can see we've got, granted the air-fuel ratio is not quite the same, but we have about let's open that actuator authority up a little bit more to give us the ability to see, to get to that stoichiometric air-fuel ratio. So we're getting about the same amount of net power out as we were before, but our pumping losses are about half to 2/3 of what they were. So we've been able to make the engine run a little bit more efficiently by changing the variable valve timing, and we can see that by using the anti-combustion analysis tools that we have available to us in order to kind of more or less verify what it is that we're doing. So the next thing we're going to do is take the engine and kind of go the other way. Rather than try to make the idle condition run a little bit more, or kind of a highway cruising condition run more efficiently, we're going to take a look at how we can improve the output of the engine by using the turbocharger. But actually, so what I'll do in order to accomplish that goal is start moving the cams back toward their park position. You can see as I'm doing that the pumping mean effective pressure is starting to go back up. So went the wrong way there on the exhaust cam. Now we'll just go ahead and turn these off so that we're running without that.